Good afternoon, everyone. I would like to thank each and every one of you for being here with us today. For those of you who don't know me, my name is Nisarg Shah, and I'm an associate professor in the Department of Computer Science here at the University of Toronto, and a research lead at the Schwartz Reisman Institute for Technology and Society. On behalf of the Schwartz Reisman Institute, I'm pleased to welcome you to the first SRI Seminar Series event of 2024. Whether you have participated in our past sessions or if this is your first, I hope that you find the series to be a welcoming and inspiring place to learn about the important current research topics at the intersection of technology and society, and to discuss the implications, benefits, and challenges for society posed by the powerful technologies like artificial intelligence and data-driven systems. We have an excellent slate of speakers lined up for this semester, and I'm looking forward to hearing from our many illustrious guests. All right, let me begin with a land acknowledgement. For thousands of years, Toronto has been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit. These and other indigenous peoples across Turtle Island developed complex and effective governance systems based on respect for all life and the intelligence of the natural world. Today, this land is still home to many indigenous people working to reclaim their rights to self-determination, and we are grateful to have the opportunity to live and work on this land. Although we may all be joining from different places today, we invite you to reflect on the history and relations of the land that you are on. Okay, a few logistics before we begin. First, this session is being recorded. Our guest will speak for about 50 minutes, followed by a question and answer period. During the Q&A, we encourage all participants to use the raise hand function in the Zoom meeting controls to ask a question. Without further ado, let me introduce our today's speaker, Pinar Yildirim. Pinar is an associate professor of marketing and economics at the Wharton School. She is a quantitative marketing and economics expert specializing in media, technology, and information economics. Combining applied theory and empirical analysis, Pinar studies online platforms, artificial intelligence, privacy, digitization, and social networks. Pinar's research has been published in leading peer-reviewed journals, including the American Economic Review, Marketing Science, the Journal of Marketing Research, Quantitative Marketing and Economics, and Management Science. She also serves on the editorial boards of Marketing Science and the Journal of Marketing Research. Numerous mainstream media outlets have already covered her work, including the CNN, Forbes, the New York Times, NPR, Politico, the Wall Street Journal, the Washington Post. In 2020, the American Marketing Association honored her with the Erin Anderson Award, which recognizes a female marketing scholar likely to become a leading academic in the field. Pinar is also a faculty research fellow in the Productivity, Innovation, and Entrepreneurship program at the National Bureau of Economic Research. So, without further ado, Pinar, the floor is all yours.
Thank you so much. I hope I can live up to that long introduction. It's wonderful to see everyone. I'm happy to be the first speaker. Let me start by sharing my slides. I was told that this is a generally broader group of academics than my general audience, who might be more coming from either business schools or from the economics departments. So I try to put everything into a slightly easier to perhaps digest format, which is on a PowerPoint, but it's still going to be a pretty academically dense talk. If at any point something doesn't sound clear, if there are some burning questions, please feel free to put that in the chat window. I've asked Nisarg to just put those questions or pose those questions at the time. But if questions can wait, I'm very, very much looking forward to discussing and getting your feedback at the end. Let's get started. So, of course, for this audience, perhaps the topic of this presentation is not necessarily a surprising topic, an unusual topic, a topic that requires lots of introduction. I'm going to be thinking about the effects of robotization, and I'm going to sometimes use the word robotization and automation in an interchangeable manner. And I'm going to think about how automation influences individuals' careers, career trajectories, career values, and those changes that we observe in career values, how that in turn might be influencing other behaviors of individuals, from consumption patterns, investment patterns, to other things that might relate to their political preferences. Now, as we are getting ready for an election year right now in the United States, of course, some of these changing preferences and how technology might be influencing political beliefs might be of particular relevance this year, and we might start maybe thinking a little more deeply about these issues. But this is going to be a joint work with Maria Petrova, Gregor Schubert, and Lady Tasca, and let me, of course, credit my co-authors. So again, robotization, if you think about robotization, AI, of course, this is at full force. We have seen, if you look at some of the recent statistics that are coming from the Industrial Federation of Robotics, we have seen exponential growth, increasing growth over the years in terms of the robot adoption. In 2021, the World Robotics Association showed about 500,000 units of robots that would be adopted around the world, installations of robots, and that actually shows quite a steep growth, about a 31% year-on-year growth. So it's not small. And the questions, of course, then follow. If you look at workplaces, gradually we are starting to see pictures of this sort, right? Humans are disappearing. Somehow they are maybe moving from tasks to tasks. They might be experiencing some displacement of jobs. So we would like to understand what's happening to these workers. We would like to understand how their careers are changed. Of course, if you think about the effects of automation, there's an amazing, of course, long literature right now, which I know, some of you, including Avi, who's in the crowd, has contributed a lot. But if you think about effects of automation, of course, we can think of many different effects. We can discuss many different effects. We can think of, for example, some of the short-term implications on wages and again, employment outcomes. We can think of maybe longer-term effects, such as changing of job task definitions and delegation of these tasks within organizations. We can think of course, with the change of those tasks, we can think of some of the power shift within organizations. This is a question that I have also thought a lot about. And we might start thinking about, of course, the spillovers across different firms, across different industries, going from one firm that is impacted heavily by automation to other firms. So there are many different potential implications of automation, but the one that we would like to think about in this particular research study is understanding the career trajectories and how they potentially change. How do we think about the future opportunities of finding jobs, employment, and potentially moving from a good job to a better job? How are technologies changing those trajectories? Because I think if we focus on just the first couple outcomes, right, those short-term questions or short-term outcomes, we might be missing the whole picture in terms of the labor market effects. We might be missing, for instance, we might see that people are still keeping their jobs, but even if you keep that job, even if automation happens and you somehow are at the same job, the value of keeping that job, that particular career, might start to look different if somehow the future career mobility, moving out of that job, starts to look bad as a result of automation. So that's what we want to understand in the study. And in order to be able to do that, we are going to undertake a big empirical sort of examination. So altogether, again, just as a summary, what we would like to ask in this question is, what are the effects of robotization in terms of career progression, career trajectory outcomes? Can we look at some of these outcomes, document some of these changes? Can we say that some of the changes that we expect in terms of career trajectories, are they due to automation, robotization? And then can we say something about the heterogeneity, potential, which sectors are most impacted, which occupations see the greatest change? Do we observe, for example, people losing some of the income or occupational mobility in their own occupations or other occupations? We are able to answer some of these questions. And again, the broader effects of these potential changes that one might observe in the career values. Now, what I plan to do in the rest of the presentation is to describe the empirical strategy that we are going to undertake in order to try to answer these questions. What I need to do to be able to answer these questions is, first of all, come up with a definition of something that looks a little bit like a career value, right? If I have a job currently, what is the value of that job to me? If I think about all the potential future career movements that I might have, right, to different occupations and the potential earnings from those jobs, I would like to first come up with a definition of that career value. Right, it's something that helps me to approximate it. And then I want to think about how different occupations, different jobs, different sectors are impacted by automation, robotization. And I will try to link these two concepts, thinking about the effects of robotization on the career value. And then I will try to decompose this as much as possible, as much as the time allows. So that's the plan. And if you're on board, let's go ahead and think about, again, this very first part, which is going to be the measurement of career values. Now, it's not unusual if you walk into any classroom, any undergraduate classroom or MBA classroom, and if you ask people about what kind of jobs they may want to have, sometimes you will see that the jobs that they may want to have is not necessarily the jobs that they are dreaming about or the jobs that they really want to have for the rest of their lives, but they want to have those jobs because the future career of those occupations seem a little more attractive. What I mean by that, sometimes, for example, we'll see MBA students go into consulting careers knowing that from a consulting career, they have an easy trajectory to other occupations. So the value of an occupation, in short, is not just about the current on-time, in-time earnings potential of that particular job, but it also should include the potential movements from that job to other occupations and those occupations' earnings potential. So we try to capture this in this paper by looking at or creating essentially something that looks more like a net present value of future wage paths. If you think about some expected wages that you can hold from different careers in your life over a period of time. And if you think about, of course, a discount rate that you might want to discount, of course, those future earnings. So if anybody could somehow project all the jobs that they can hold in their life, and somehow anticipate also correctly the future wages, they could simply discount the future and sum them up to come up with the net present value of keeping a particular job at this time. But of course, that requires a slightly more maybe intensive operation that to be estimate the expected career value of holding a particular occupation, or let's say, in a location, because wages and the trajectories might depend on the location of an individual, and at a particular time, because again, the future projections might change over time, it might require something that looks like this first object, the pie, the likelihood with which somebody is going to move from one occupation to another in a given location at a given time, and then the earnings potential of the current job, essentially that one is moving to, P, and the future potential earnings from moving from that particular job, P, into other occupations. So we can write this equation in a recursive manner, and then, of course, we can then create a simpler expression to be able to calculate the sort of long-term steady-state career values of different occupations. But if we wanted to estimate something like this using data, what we essentially need is an approximation of that transition matrix going from one occupation to another for different regions and different times, and the wages that one needs to be able to integrate or include into this particular expression. So to be able to do that, to be able to gather an approximation of this transition matrix and the wages, I'm going to rely on sources of data. In particular, the one that we really rely on, the one source of, let me get rid of the floating controls. The one data source that we really rely on here is going to be the Burning Glass Technologies dataset, which essentially is about a dataset of about 16 million resumes from the United States, submitted online by US workers through mainly a period of 2000 to 2016. And it acts as a panel to the extent that, of course, this provides a complete history of a worker. We can observe what job people had in a sequence with the start and end dates. We can observe some of the educational characteristics of individuals. We know the job, again, with a standard occupational classification definition, as well as the employer, so that we can understand the movements of different types of workers when they have a particular job. Now, we do have some information about the other characteristics of individuals, like we can approximate age, we can approximate gender and location, but we are not going to heavily rely on these characteristics. What we are going to do is use about this 178 million sequential worker year observations to approximate a nation level transition matrix. And then we'll start weighing those transitions by the local labor market characteristics. For wage, and I'll go into the details of this in a second. For the wages, we are going to rely on the official data sources. We are going to use the occupation and state wage characteristics from the Bureau of Labor Statistics Occupational Employment Statistics Survey. So let me dive a little deeper into this transition matrix and the weighing, because this is, I think, one of the contributions that we are making in this paper. What we are looking at is we are going to, again, try to understand if you have a particular job in this year, what are the chances that you are going to move to a different occupation within the next year? So we will look at all the people who are holding an occupation O, and then we'll calculate the shares of people who are moving to a different occupation P, where we define occupations by, again, the official standard occupational classification code characteristics, so about 700 occupations and a matrix of 700 by 700. But we understand that, of course, these occupations do not present themselves at the same rate in different regions. So in order to account for the regional characteristics, regional differences, we are going to then weigh these probabilities by the shares of occupations that we observe in different regions. And when I say region, we are going to think about the commuting zones in the United States. So this gives us, again, an approximation of how likely a worker who is currently at a particular occupation, let's say an assembly line occupation, how likely that person would be to move to maybe a supervising occupation within the next year if they live in a commuting zone near Wisconsin, and then we would have a different probability for someone who might be in Pennsylvania. So we are going to take, again, these probabilities, and we are going to use them in order to calculate career values. And again, we are, of course, using a discounting factor, a standard discounting factor of about 0.85, 0.9. But we are going to think of a potential employment that can last forever. And we are going to then first carry out a descriptive exercise of how career values looked for different occupations and how did they change if you look at the most recent times that our data allows us to look at. So it's going to be a 2000 to 2016 period. So let me tell you a few descriptive things about how career values look like in the United States, the changes in career values. And the way that I'm going to try to describe some of these changes that are taking place is going to show you a graph where on the x-axis, you are seeing an approximation of a starting wage by occupational classification, a two-digit occupational classification, different categories of jobs. You can see the average starting annual wage. And on the y-axis, what you are going to see is going to be the change in the career value through this period of 2000 to 2016. Here, we just wanted to reduce noise, so we are taking a 3-year average in the x-axis. That's why you're seeing this 2001 number, but it's essentially an approximation of the changes that are taking place in this time. So now we can look at this figure and we can see that different occupations experience different changes, right? We like to, as business school professors, we like to highlight management, which is on one corner, started out with high wages and ended up seeing a positive change in the career values. But of course, there are other occupations that have experienced different changes, right? If you look at legal occupations, it seems like they were at a fairly good place in terms of the earnings in early 2000s, and somehow they experienced some losses in the potential, right? The earnings potential of the jobs that one can move out of the legal careers. But then you have, aside from management, you have, of course, this other extreme where you see fishing, farming, forestry jobs, which started out from a fairly low place, but somehow sees the ability to move to better careers. So again, here we see lots of heterogeneity, and we can say different things about different occupations. But what I want to also highlight here is that this is not just about the changes in wages. If we were to just plot this, the same figure, for the changes in expected wages, right? Here I have the same x-axis, but I'm just plotting the expected annual wage changes throughout this period. You can see that this figure is a lot flatter. So something else is changing in this period, or there's a lot more heterogeneity when it comes to the possibility of movement across different jobs. So that's clear, I think, from the comparison of these two figures, right? You can see that it's not just coming from the wages. And on top of that, thinking about, again, the occupational mobility, right? We can also look into the ability to move out of different occupations, right? So what I'm going to show you here in this figure and the next figure is going to be a comparison of 5 yearly periods and the likelihood of moving out of occupations, again, starting with the comparison of 2000 to 2005 and 2005 to 2010, the next 5-year period. And then in the next figure with these 2-digit occupations, I'm going to show you how the 2000 to 2005 figure compares to the next 5 years, 2010 to 2015. So you can see easily that there's actually a movement, right, to the right-hand side of this 45-degree line, which essentially implies a general trend. Of course, different occupations experience different levels of this reduction, but a reduced mobility out of the occupations. So this is something that we observe. And of course, we want to understand if some of these changes in the career trajectory or decline in mobility can be related to automation or technological shifts. Now, in order to be able to sort of answer this question, the first thing we do before doing anything with automation data ourselves is to plot or observed from our data, observed career value changes against the occupational job automatability scores that were calculated by Frey and Osborne in their 2017 paper. So in this paper, the authors are calculating a computerization or automatability score for different occupations using a combination of understanding decomposing tasks through task definitions and additional tasks. But here they are able to create for a long list of jobs a likelihood of computerization or automatability. And here, when we contrast the likelihood of automatability to the career value changes, we can see a very clear negative relationship. The more automatable a job was predicted to be by an outside source, an external source, Frey and Osborne, the lesser of a positive career value change we observed in our data. And on top of that, when we look into some of the transitions out of occupations or not into occupations, here we are thinking of a comparison of 2004 and 2016 out of production, again, automation-related occupations. And here we can see also some changes. This is very descriptive, of course, but some changes. Here, the size of these bubbles show the probability with which someone who holds a production occupation would be moving to an occupation that is essentially let's say, for example, for the large blue management occupation, and the bigger the size, the higher the probability. The relative probabilities, of course, seem to be going down for a number of occupations. If you started out with a production occupation from 2004 to 2016, we see in particular the ones that we think are interesting are these declines of relative probability in management and architecture and engineering, and similar sort of vertical transitions that one may anticipate, right? Business and financial looks slightly comparable, but again, there does not seem to be an increase. So we want to ask these questions. Is there indeed a relationship between the amount of automation, amount of robotization that's going on, and occupational mobility and career value changes, and can be quantified? That's going to be the next thing that I'm going to try to do. Again, link the concept of robotization to career values, but I want to do this, of course, using our own automation data. And in order to be able to do that, of course, I need that automation exposure measure. And I'm going to go into the details of that automation exposure here. So in general, though, what I want to do here is to look at regressions of this type, where on the left-hand side, I have some outcome measure that's going to be an aggregated measure of career value changes. And on the right-hand side, I have an automation exposure measure. And I want to, of course, control for some characteristics that might be unique to a particular region, some characteristics about the labor market, and understand the sign and the sort of magnitude of this gamma 2. The automation measure, the exposure measure that we use is going to be something somewhat standard, perhaps, now in the literature. We are going to think about a commuting zone level robot exposure of workers relying on the work that was done by Ajamoli and Restrepo. We use a similar strategy in terms of calculating automation exposure with a couple exceptions. We look at a different timeline for the most part than they do. And we are going to use essentially an IV lasso to be able to pick the instruments, but let me go into the details. So how do I think about automation and robotization? Now, we want to think about the changes that are taking place over a period of time for an industry. The ideal exercise, of course, to be able to carry out in this case would be to use data exactly at the firm level. If we had the number of robots that are adopted by different firms at an aggregate level, maybe we could map that to workers. We don't have access to this data, but the data that we have access to is the International Federation of Robotics data, which provides at the country and year level the stock of robots and the operational robots that are relating to different industries. So for example, we can see that for industry A, between 2000 and 2016, there were additional 4,000 robots that are introduced. Now, those 4,000 robots will relate to a number of different workers, but of course the effects are not going to be the same across different geographies. In particular, if Pennsylvania had 50% of their workers in this industry, we might imagine that a higher share of the workers in this region are exposed to robotization compared to, say, another state, California, where only 10% of the workers are in this industry. Now, because we know the robots that were assigned, that were installed, and which industries these robots relate to, we can carry out this exercise for different industries, right? We can look at another industry and see that maybe there were 6,000 robots added, and worker shares across different regions look differently. And then we can calculate how many robots per worker were essentially included in terms of shares, aggregated across different industries to come up with a rough measure of automation exposure. Now, of course, doing this and trying to use an exposure measure of this sort is going to be problematic for a number of reasons. It's going to be, of course, endogenous to the worker and labor market characteristics. It's going to be endogenous to some of the changes that might change both career values and robot adoption, right? These two things are happening simultaneously in a correlated manner. So in order to be able to reduce the concerns of endogeneity, we are going to first use something that looks more like a bar ticket shift share instrument. We are going to use an approximation of share of workers in different industries in different regions based on time invariant characteristics. So we are going to rely on shares that are coming from couple decades ago, from 1990s, as opposed to the most recent labor market shares. Again, the idea is to rely on time invariant characteristics of why workers might be in different regions, in different industries, at a higher or lower rate. And a second thing that we are going to do, we are going to instrument the adoption, the US robot adoption on the robot adoption of other countries. We again use an IV lasso approach, and let's essentially rely on a machine learning tool to be able to choose the instruments. But what that might imply is that we are going to, for example, instrument the robot adoption in the United States based on the robot adoption rates in a particular industry, coming from Sweden's robot adoption rates and Denmark's and let's say Spain's. And the idea for doing that is to remove the characteristics that might be about the local labor market conditions, but rely on, again, the common characteristics, which might be, again, more about the technological progress that increase or reduce sometimes the robot adoption rates in different industries. So just we are going to rely on the robot adoption rates of different countries and instrument the US robot adoption on those countries. So this is more of a standard thing for those who are studying this literature. I guess this explanation might be too detailed, but hopefully that addresses some of the endogeneity concerns. And when we carry out this exercise, what we are going to see, now this is without any removing any fixed effects, what the US robot automation exposure numbers look like. And this is, of course, before instrumentation too. Here you can see the number of robots per 1,000 workers across different counties. This is at the county level. You can see, perhaps not too surprisingly, the heavier, more intense robot adoption areas are more around the Rust Belt area, right? You can see Michigan, Indiana, and some of Pennsylvania being among the states where the exposure is higher. Similarly, if we just take into account the division, these are the 9 divisions in the United States, division fixed effects to remove some of the time invariant characteristics that are about the regions, we still see a similar pattern. Although if I contrast the 2 pictures, you can see that now we also see perhaps a greater exposure around the West. It still seems like the highest exposure has been around the Rust Belt area. So now let's take all these measures and try to link career values and robotization together. I'm speaking pretty intensely. Hopefully everybody is following. But now what I want to do is to take those individualized or occupational level career values and calculate a regional average aggregated career value of occupations. And in order to do that, I'm going to take into account, again, the C's here that you observe, that is the career value of a particular occupation in a region, and the labor market share of the people in that region of that particular occupation. And I'm going to aggregate that across all the occupations to come up with an average career value of the occupations in a level. And I'm going to put this expression on the left-hand side of an equation. I'm going to put on the right-hand side the changes in automation exposure to see if there's a relationship, again, instrumenting on the adoption rates of other countries to be able to make a more causal interpretation. Here is a table that actually shows, again, the IV lasso results coming from the robot adoption exposure rates. We can carry out this exercise looking at different time periods. We can look at, for example, the change between 2004, 2008. We can look at changes between 2008, 2016, 2004, 2016. But regardless of the time period, we can see that there is a decline in the average local career value of the occupations in regions that have been more exposed to automation. Now, to quantify this, essentially we can look at different time periods, but roughly a 3.3 thousand for 2016 period, and about a 3.8 thousand decline on average this is what's corresponding to adding 1 additional robot per 1,000 workers for the period of 2004-2008. Now, some of you might look at this number and say, well, that looks small. But again, this is the average effect, right, at a region for per 1 additional robot per 1,000. Some regions are a lot more exposed to robots, going as high up as 9 additional robots per 1,000 in this time period. And of course, some occupations might also be a lot more exposed to automation than this number. So we think that this is still a meaningful number. And then we'll try to understand and decompose the effects of these numbers. Now, what I want to do next is, after showing that there is a decline in the average career values, try to understand the sources of that, right? This might happen because potentially some jobs are becoming extinct in certain regions, right? It's possible that in some commuting zones, jobs are disappearing, and as a result, you cannot move into those occupations. It might also be that those jobs still exist, but somehow the future, right, career value expectations, the future trajectories for those occupations change. So the first decomposition is, for this purpose, to be able to understand, is it the disappearance of occupations in different regions that's causing this decline, or is it the fact that the value that you can have, the future earnings of these occupations are changing? And I'm going to show you results in 1 second. And the second thing that, of course, we can do is, if we see a change in the sort of future earnings potential of an occupation or in an area, is it the case that the wages, that the future earnings are declining, or is it the probability of being able to move to those occupations? Is it what's changing? So we are going to carry out a second decomposition to understand the effects of automation. Is it the wages, or is it the occupational path, or to what extent are these forces in effect? Now, this is essentially the same thing I mentioned, written in a more complicated language. But the first thing I do, and I am basically highlighting in these columns, let's understand, is it the local occupations, the composition of the local occupations changing? That's column number 1. Or is it the career value, the value of the earnings potential of the careers that are changing? And of course, there's always an interaction between the two. And we can say that the changes, the declines in the average career value are not substantially due to the changes in the changes in the local market job composition. So it doesn't seem like it's coming, or it's mainly driven by the changes in the local opportunities, but it seems like something about the jobs that we hold and their future earnings potential is going down. Now, let's decompose that then, decompose column 2 into the declines or changes, increases in wages, and the change in the occupational trajectory. So that's what we do. And here we can see in columns 3 and 4, again, of course, there's an interaction of those two in column 5 as well. Here we can see that there is both a decline in the wages that people can expect to have in the future, as well as a change in the occupational mobility, the likelihood of being able to move to different occupations, the higher the robot exposure. But we can, of course, quantify the size of these effects. We see that 2/3 of the effect is due to the decline in wages, so it's still substantial. But there is also a significant part of this decline that's coming from 1/3, roughly, coming from the decline in career path or being able to move to upward careers, the careers that give you a higher earnings potential. So again, here I think the overall takeaway is that we talk a lot about the potential disappearance of occupations, and this is very important. But what we are seeing, even we are in this picture, what we can document is that when areas, commuting zones, are more exposed to automation, we don't necessarily see the declines in the future earnings potentials of individuals because of the disappearance of these jobs, but there's something about the jobs that stay and their earnings potential, the wages that these occupations can hold in the future, as well as the occupational mobility from these occupations that seems to be changing, and that seems to be looking worse. And I think this is a very interesting and important outcome of technological change that we have to keep in mind. Now, here it's a more crowded table, but essentially what I'm doing is I'm just going to separate what I just mentioned, these effects, into two different regions: the high manufacturing commuting zones and the low manufacturing commuting zones, the ones that are more intensive in terms of the manufacturing intensity and the ones that are less intensive. And we can see, of course, here, AO instrument is stronger for the high manufacturing commuting zones, but we can also see that the overall effects that we observe are heavily driven by the high manufacturing commuting zones. In the second panel, you can see that that's essentially the case. So something about, again, high manufacturing regions and robotization that seems to be supporting the decline in the career values. Now, we can ask again these questions and try to see if we can see further evidence. Here, I'm going to look into a regression where we look into the effects of robotic exposure on the likelihood of transitions, the probability of transitioning to an occupation that holds roughly the equal wage, a higher wage, and a lower wage. And here we can see that the more exposed a region was to robotization, we could observe essentially a higher likelihood of moving into a similar wage transition when we look at the transitions that the workers carry out, a lower likelihood of moving into a higher wage occupation, and no change in the likelihood of moving to a lower wage occupation. We can carry out this exercise again separately for the high manufacturing and low manufacturing commuting zones. And here we can see that, for example, the probability of moving into an equal wage seems to be indeed that positive effect that we see is coming mainly from the high manufacturing regions. The same thing when we look into the decline in the likelihood of moving to a better paying occupation. This effect it seems it's coming from the high manufacturing regions. And finally, of course, a sort of a similar sort of picture when we are looking into the likelihood of moving to lower wage occupations. Separating high manufacturing regions and low manufacturing regions actually gives us a picture that people are even more likely to move into lower wage occupations if we just focus on the high manufacturing areas. So it seems again that there's something about the likelihood of movement and upward trajectories that that are looking different for many different manufacturing regions, different intensities of manufacturing. And that does not seem to suggest that higher robotic exposure is helping people to move more easily to better paying jobs. It seems like it's the opposite. Essentially exactly the same things that I mentioned. So I'm going to move into yet another decomposition. Now, one other question that we can ask, again, I do holding controls. One other question that we can ask is, are the robot exposure, is the robot exposure resulting in career values mainly from my own occupation, or is it coming from the occupations, the other occupations that I might move into? And of course, we see with higher robot exposure in a region, both a decline coming from one's own occupation, the occupation that they hold, as well as the occupations that they might be moving into. But when we compare the magnitude seems to, the magnitude for the decline seems to be larger for the other occupations as opposed to the own occupation. So they yet again another evidence that we can talk about in terms of the reduced occupational mobility with increasing robot exposure for the individuals. Now, we do carry out a number of additional exercises. Just to sort of briefly mention, we look into, for example, are people more likely to change occupations or change employers, change firms within occupations, change occupations within firms? And here, we suffer from weak instruments in some of these regressions because we are decomposing the data quite a lot. But at least there seems to be a relationship between the robot exposure, high levels of robot exposure, and the sort of movement across occupations. It seems to be a negative relationship between the two, and a positive relationship between changing employers and robotic exposure. So again, perhaps speaking to reduced ability to keep your occupation, the same occupation within the firm. So there are a number of other things that we can talk about, right? We can say, for example, well, do we observe maybe changes in the distribution of the career values within a region? Are the highest end of the distribution perhaps earning more compared to the lower end? Can we talk about inequality? And here, what we do is basically running a number of different regressions, comparing different values. For example, we can compare the 90th percentile relative to the 50th percentile of career value distribution in a region, do the same thing for 90 to 10. But you can see that also the distribution seems to be less equitable, or it seems to be slightly more negative, less equal. If you look into the career value distribution across within regions, across individuals. So this is yet another negative effect. The question is, now, if we are observing all these potential negative effects, what does it do to individuals? And is this just the manufacturing thing, right? Maybe there are some regions like California, which are perhaps a little less manufacturing intensive, and they are going to be completely, unaffected by these effects. Now, the first thing, I'm going to speed up a little bit in terms of time, but the first thing that we see, we don't really see that this effect is contained in manufacturing. When we look at the jobs and their career values in different sub industries, retail and wholesale, services, management, other industries, we see that the negative effects are basically replicating across different careers, different sectors, different type of jobs. This is not just the manufacturing effect. There's something about these regions where robotization seems to replicate across different jobs, different non-manufacturing jobs. And this figure essentially shows the same thing, decomposing into further industries, that we see negative effects, not just in manufacturing, production-related jobs, but other jobs as well. Now, we ask this question, right? Why is it that we are observing this negative spillover? Could it be that maybe the jobs that are impacted by robotization are common across different industries, just like the typewriters impacted administrative jobs, or the likelihood of maybe earnings from those jobs that were common across different industries? Maybe these robots are impacting certain jobs that are common across different industries. It seems, at least looking at the data and the type of these robots, an unlikely explanation, but we don't completely rule that out. Second thing might be that, of course, the workers in one industry are impacted, right? They lose their bargaining power and they want to move into other occupations. If that's the case, we might see perhaps higher levels of employment in other industries now that we have these workers with lower bargaining power, right? They might be moving into other industries, but losing their wages. So that could be a potential explanation. And a third explanation could be that as these individuals are losing some of their earning potential, they're less likely to spend money in other industries. For example, I lose my earnings potential and now I'm less likely to go to a restaurant, or less likely to get a haircut, and less likely to maybe spend money. So we want to see if we see any evidence of these potential explanations. And let me say, in short, that we are going to see essentially, this is employment and automation shocks. We are going to see automation effects not on just the manufacturing jobs. We in fact see a potentially more negative effect in other jobs when we look at employment effects. So it doesn't seem like people are moving from the manufacturing jobs to other places and somehow the employment is increasing in other industries. It doesn't seem to be the case. The same way, we see the wage declines in manufacturing jobs, but we also see wage declines in other industries. So this idea of bargaining and somehow losing bargaining power in other industries in terms of wages might potentially have some support. But we also see, when we look at, for example, consumption patterns, and here I'm showing you the consumption patterns of households in different regions using the Nielsen Home Scanner panel data, looking at their retail spending. We are also seeing, again, adjusting for inflation and so on, for the households that we can keep consistently across the panel, a decline in their spending patterns. You might say, okay, these households are maybe getting, older. We don't know, of course, they are going from younger to 20s to 30s to 30s to 40s. But again, the effect that we are documenting here is the cross-sectional differences. Everybody's aging potentially across the nation in the same pattern, but the individuals who are more in the impacted regions, robotization impacted regions, seem to be declining their spending a little more. So there seems to be, again, this relationship between the spending patterns. And another way we try to document this is looking into the local businesses and businesses that might be operating in a way that serve other regions. And one definition of this is coming from Yan and Sophie's 2014 paper, where they look into tradable and non-tradable businesses, where the non-tradable businesses are mainly the businesses that operate within a local region and their output is consumed by the local region. There's, of course, a much more restrictive definition that I can give if anybody is interested. But what we are seeing here is especially a negative effect on the non-tradable jobs. We put construction just as another sort of benchmark, which is also pretty local oftentimes. But we can see that for the non-tradable jobs, if you look into either the number of establishments in column 2 or the employees per establishment, we see a general negative effect also with higher robotization. So altogether, it seems like the drivers might again come from maybe potential losing bargaining power of the workers, as well as the fact that some of the spending, the earnings potential decline, and some of the spending in other industries are declining, which altogether starts to negatively impact those other industries as well. So we see some suggestive evidence in this direction. Then we ask other questions. We ask, for example, if we observe these declines in these particular regions, do we observe any change in the investments that these people make? We ask also questions about their beliefs. The one thing that we observe is perhaps not surprisingly, in these regions where we observe high robotic exposure, people looking at the Gallup surveys and these annual Gallup surveys that essentially cover about, if I recall correctly, 60,000 individuals, they do mention that the economy is not, they're less likely to mention that the economy has gotten better. And they, in fact, if you think about this as potentially a dichotomous answer, of course, that would imply that they are either thinking the economy is equally the same or has gotten worse. But generally, I guess, a negative perception of the direction of the economy in these regions where the automation exposure was higher. When we look into the predicted career value changes, again, as an outcome of the automation exposure and how likely people are to invest into education, invest into housing measured by the number of new permits that are issued, and looking into some of the voting pattern changes, what we see is that, of course, you can see here a positive correlation between the local market career values and share of individuals in college, share of housing permits, which implies that as robotization increases and local market career values decline, we'll see fewer number of people investing in education, we'll see fewer number of people investing in housing permits, and we'll see potentially higher shares of the GOP vote for the 2016 election. In the last part, very briefly, I'm going to decompose this. Now, we carried out an exercise where we looked at the voting shares of different presidential candidates. Of course, having the two-party helps. Looking at this, the difference between Republican and Democratic candidates. While we do not observe the same effect for other years, we observe a unique effect on the 2016 election, which was the Trump year. Here, essentially, what we can observe is that one additional robot per 1,000 workers resulted in a 0.4 percentage point higher increase in the vote share for Trump as a candidate in the regions, again, that were exposed. So the more exposed the region was, the higher was the vote for Trump. Now, these are some of the observations that we have. And you might ask questions, well, do you observe some heterogeneity across these results? And I can say that the effects seem to be pretty consistently happening across individuals with high skills, higher education levels, lower education levels. Of course, there is some variation, but in general, we see the higher education seems to be potentially a shield for less negative effects, but does not necessarily eliminate all the negative effects. So I think I am pretty much at the end of my time here. Let me just sort of wrap things up and open the floor for questions. So in this study, we have many different sub-analyses, but what we try to show is that automation or robotization and some of these technological changes do not only influence wages in the short term, do not only influence potentially the displacement of occupations, but even if you keep an occupation, the potential future earnings from holding that occupation might be changing also with robotization. And more importantly, we see on average a negative effect of robotization in regions that have been more exposed to automation or robotization. We see greater declines in the average local market career values. We see that this negative effect is not contained only to manufacturing occupations, but it seems to spill over to other occupations. We try to understand why that's the case, and we see some potential evidence that might be consistent with A, workers losing their bargaining power, and B, consumption declining, potentially due to the lower earnings, the consumption declining across different industries as well, potentially resulting in a negative employment outcome for those industries as well. And we show that these declines that are an outcome of the technological change also have negative potential implications for outcomes like investment in education, investment in housing, again, consumption, but also it seems to be impacting the voting patterns that we observed. Of course, we only see this in one particular election. We don't know if this is going to replicate in the future elections, but in terms of understanding the motives of voting and motives of political behavior, perhaps this is also a useful analysis. So thank you so much. I appreciate all the patience. This is an intense sort of slide deck. I would love to welcome questions and comments. And if you have anything else, you are more than welcome, please, to reach out to me through my email.
Thank you so much, Pinar. That was a fantastic presentation. And we are happy to move into our discussion period now. And we welcome questions from all the participants. So if you're in the audience, you have a question, please use the raised hand or the chat function in Zoom to if you would like to ask a question. And when I call upon you, I would welcome you to turn on your camera to ask your question if you are comfortable doing so. If not, just let me know and I can read out your question. And our team will send you a request to unmute when it's your turn to speak. All right. So I see a number of hands already raised here. Shreyas, do you want to unmute and ask your question?
Yeah, thank you so much. Pinar, hi, great talk. Really enjoyed it. Very exhaustive set of results and mechanisms. I think you touched upon this in a few places already, so I'll keep the question brief. But do you, I'm thinking of some career changes as being horizontal and some as being vertical. And do you, and especially during election years, you see this talk about teaching new skills to manufacturing workers. So do you see some evidence of people either who've successfully transitioned to new industries, or what are the kinds of transitions that people who've been displaced end up with?
Mm-hmm. So, I mean, we don't necessarily focus just on people who are displaced, but we see transitions, and we do see, again, just going by the two types of classifications. One is, of course, thinking about what kind of jobs people are moving across. So we see lower movements to, for example, management occupations. If I focus on production occupations, lower likelihood of moving to management occupations or engineering and architecture type of occupations. what would that mean? And you might be surprised, well, do people in production move to engineering or management jobs anyway? But by definition, for example, if you're the supervisor in an assembly line, that is a management occupation. So we see lesser of these occupations. I would say that it's, again, once you start decomposing across occupations, it's difficult to say something from a statistical perspective, but at least just as an observation, some of the movements that we can observe are potentially more horizontal. For example, you might see people moving into something along the retail line, right? So becoming a retail associate and so on. So those type of movements where, of course, you have many different movements of this sort seems to be a little more observed in 2016 data compared to 2004. But again, once you start running statistical analysis on these, we run out of power, and I would only speak to this as a correlational outcome. I don't know if that answers the question. This is, of course, one part of it, the type of jobs. And as I mentioned, of course, if we just generalize looking, across different jobs, if you just start aggregating them into lower payment, higher payment, we see that people are moving to, especially in regions that have been more impacted, they're more likely to move to similar payment jobs, and less likely, so they're more likely to less likely to move to higher paying jobs. In the high manufacturing areas, also more likely to move to lower paying jobs, but that doesn't differentiate across different jobs. Okay.
Thanks, Pinar. So actually, this relates to another question that was asked on chat, and Sepide has asked me to read out their question. So let me go a little bit out of the order and take that question now, if you want to add some more remarks on for that. So they ask, hello, do you think that the migration of workers between the regions during this period might have affected some of the results?
Yeah, this is something that we have actually thought about, and I recently became aware of a paper that also looks into this particular relationship between by Marco Tabellini and co-authors, looking into whether there's an effect between automation and migration. So in general, migration is fairly uncommon in the United States. It's not a very high share of workers that seem to be migrating. So we thought about this at some point, and we tried to integrate the migration. Unfortunately, we don't really observe we can observe state by state in and out migration patterns that are in official data, but in our data, unfortunately, we don't observe people's migration. So based on those overall migration rates, we do not think that is going to take away all these outcomes, but unfortunately, that's just something that remains as a potential. I don't think that it's going to take away, again, eliminate all these results, but it's something that is a weakness of the study. We would love to be able to, of course, see, as we look into these 16 million resumes, how people move potentially across regions, which is something that we don't observe.
Thanks for that answer. Next up, Dan Goetz has a question. Dan, would you like to ask your question?
Yeah, for sure. Thanks, Pinar, for a great presentation. I guess this kind of builds off some of the other questions that we've just heard. So in the sense that, like, kind of one of your headline results is that robotization kind of leads to reduction in these lifetime career values because of a reduction in mobility. Do you have any sense of kind of what the mechanism behind that reduction in mobility is? It that the jobs are disappearing and so you just can't move to them? Is there greater like fixed costs, maybe like retraining costs? So I think maybe this could have implications for maybe what policies we want to design to address this issue.
I think it's a very important question, a great question. And I have a few sort of ideas, but I don't have, of course, an evidence of any of these things. So I think there might be a couple of things that are going on. Of course, some jobs might be disappearing altogether. But at the same time, for other jobs, for example, if you need a pipeline of people with certain many years of experience to be able to get to the next level, and if we have fewer of these opportunities now, and if we cannot prepare people to be able to move to the next job, so I think that might also be resulting in potentially lower levels of experience. The changing job definitions or the tasks that also maybe not sufficiently prepare people for the next job might be another part of this. So I'm again thinking of this outcome of maybe fewer assembly line workers becoming a supervisor. if you need to be in that particular occupation for a number of years, and if you need to go through a different set of experiences to get to the next level, maybe reduce robotization or increase robotization and reduce opportunities do not allow you to be able to make that move. So I think it's a combination of different things, changing opportunities, maybe reduce opportunities to prepare people for the next level, or it might be the changing job definitions, but there might also be many other factors. So this is a sort of unfortunately speculation on. Thank you, though it's a very important thing that we should think about.
Thanks, Pinar. Next up, we have a question from Luke. Do you want to ask your question, Luke?
Sure. Thanks so much, Pinar, for this very interesting talk. So I recognize that these are all correlational results. Nonetheless, right, the results seem to fit with a narrative about, right, the impacts of automation on, you know, on living standards and by extension political outcomes. I have sort of two questions. One question was, have you been able to get data for the 2020 election to look at some of these political correlations? Maybe not. That may be a simple question. But the maybe less simple question is to ask about how you see these results fitting in with evidence from other methodologies, right? So we have and the kind of causal questions, going back to this point about policy, that you know, that judgment about these results' relationship with other methods might produce, right? So for instance, right, why is automation taking place, right? You know, a sort of kind of left-wing critique would say, well, right, what these results are showing would be that automation is being used to strip these areas of you know, wealth and, you know, labor productivity, which is, you know, so the jobs are still there, but they're not as good jobs, and the people don't have as much money, right? So that suggests a particular kind of stance towards automation, versus the kind of critiques say that, you know, everybody in Indiana is watching Fox News, and so is you know, is being brainwashed, let's say, right? So I wonder how you see these results and the causal question within them interacting with policy.
So we try to at least push for the causal explanation as much as possible, using again, instruments. And we think that, again, there seems to be a very clear correlation. We've done a number of additional exercises that I didn't have in the slides. We look at, for example, the scores of the speakers within the House, whether they are acting in more Republican, more conservative, or more potentially more democratic ways, if there's some kind of polarization that we observe. We look at the number of town hall speeches. We look at a number of different things. The one thing I can say about the Trump year, when you actually start looking in a little more detailed way about his campaign, for example, for the 2016 year, 2/3 of his campaign, the town hall talks were actually in the Rust Belt area. So he seems like, at least it seems like he's very strategically targeted some of his appearances in these areas too, which might be one of the reasons why we see this relationship. And when we looked at some of his town hall speeches, he very explicitly talked about this. He mentions, for example, you know, this factory has closed and now you are out of job, and Washington, D.C. has forgotten you, and so on. So he definitely talks about some of these changes that are happening. So that might have been one of the reasons. The 2020 year we didn't look at because we don't have unfortunately, our resume data ends by 2017. So we don't have the ability to, we might be able to perhaps gather more data and try to extend it. But speaking to how long projects take, we started this a while ago, and we don't have that more recent data to be able to say something. Now, I want to keep it as quickly as possible, but I think there's a lot that's changing. So again, there are so many anecdotal stories, evidence, or people's stories narratives that seem to suggest that there's some decline that's happening at a regional level in these places. And we want to be able to say something about that. It's very difficult to be able to quantify that. So I'm never going to claim that we are quantifying, we are doing everything that one can. But I do believe that a number of things are changing along with the earnings potential with these jobs. As you mentioned, as you alluded to, the potential status of these occupations might be changing, and with those maybe declining status of some of these occupations, perhaps other characteristics within a region and how people feel about themselves, some of these things potentially might be changing. We unfortunately don't have any evidence or any way to be able to estimate that. We've looked into some correlations using some data, but I think this requires so much more examination to really understand what's going on in these regions and how we can potentially help the regions if there's any decline that can be reversed. So a long answer, but
We love long
Go ahead.
answers.
I think
Thank you, Pinar. We have a question from Jillian.
Hey, thanks, Pinar. Great talk. I have a couple of questions, and Nisar can ask me to direct my second one later. But anyway, so I missed the definition of robot, but I asked it early on, but took it from what you were doing, that you're looking at embodied AI systems. But I did wonder, one, to what extent are you looking at, like, what is your definition of robot here? And the reason I want to dig into that a bit is, one, to say, okay, if you're looking at manufacturing industries, we could be thinking about all kinds of automation and comparison to automation effects, that, like, what's so special about it being a robot that was built with maybe machine learning rather than conventional programming? What's the difference? Why do we care? The second part of the question, maybe it's the second question or second part, Nisar can judge, is what are the implications for this, or have you thought about, maybe I'm just asking if you haven't been working on this yet, you could speculate about if we start to think about those disembodied intelligence introduced into the workplace, which of course, sort of generative AI, I don't know if you know the, sort of Daniel Rock's type stuff on GPTs, and where we see a very different pattern of impact on, we see most of the impact at that higher wage, higher education levels, and so on. So maybe you could just place this project in that spectrum. Thanks.
Absolutely. So I think it's a very important question, and thinking about, so the unit robot definition that we use is consistent with what the International Federation of Robotics is using. These are machines that are primarily carrying out automation in the sense that it's repeated tasks that might have been handled manually before, and they are now repeatedly handled by a machine. We don't unfortunately know to what extent the automation is coming from a software versus a hardware. My speculation, looking at the data, again, we see some robots are in service industry. Some robots seem to be even in education. We unfortunately do not know exactly what that robot is used for. But very heavily, these robots are actually in industries like automotive. So it seems like very heavily, majority of these robots go into manufacturing industries. And I would imagine those are a little more perhaps hardware intensive, or again, replacing manual tasks as opposed to perhaps automating some of the tasks that were the cognitive tasks that were done, just like AI. So I would think that, again, the declines that we observe are probably associated with that, because this is impacting, again, the lower end of the pyramid of workers, if we think that way, perhaps the less skilled, and maybe the jobs that are closer to an entry-level job, the jobs that might have a lot more to go in terms of upward movements. Now, if you think of the effects of AI, we might see, again, potentially some declines if we think that it's displacing some workers, or reducing those workers' earning potential, or reducing those workers' bargaining power in the marketplace. So I would imagine the effects to be in similar way, but whom it impacts is going to look presumably very different. The AI is more likely to impact probably the skilled individuals as opposed to the lower skilled individuals. So that's just a sort of prediction without, unfortunately, seeing the data exactly and replicating the same analysis with the data. We don't know which way it moves. But again, some of the things that are about potential displacement of jobs, unless we create new jobs that are of higher value and somehow people are having easier time moving into those jobs as a result of AI technologies, I think the effects might be in the same direction. But we are curious. I mean, we'll see. Maybe we can get the data and repeat the same analysis, perhaps with AI, hopefully.
Thank you. Next up, we have a question from Sam.
Yeah, hi. Gillian asked pretty much the same question I was going to ask, which is the definition of robotics. So I'll just build off that and ask, it sounds like that was a pretty broad definition, like not specifically requiring machine learning, for example. And so what that makes me wonder is, how does this research exist in the history of similar research into robotics, like going back to the invention of the conveyor belt, for example? Is this just a continuation of rather than this being like a discrete boom in automation, is it just another step in a very long story of automation?
Yeah, it's a great question. So it might be, of course, one thing that we observe both with automation and AI is the scope and scale of the number of industries it has impacted. And industrial revolution, I guess, in terms of the scope and scale, might have been a little perhaps narrower, and at the same time might have taken a longer period of time, which might have helped individuals to potentially adjust over time. So in terms of automation and again, AI, I don't think we have necessarily something that doesn't look like the previous technologies, but sort of, I think, to echo some of the arguments that are also very oftenly argued by Darren Acemoglu and colleagues. These technologies always have these very heterogeneous impacts, and the effects that they have are also defined by the regulations that we put in place and some of the responses that we give as companies, policymakers. We want to document those, not necessarily because they are very different, but we will probably observe, again, these changes that are going to create winners and losers. In this case, it's going to create winning and losing regions. Potentially, it's going to create some companies that are winners, some companies that are losers, and it's going to create some employees that are very heavily negatively impacted and others not so much. So we want to understand essentially these effects, and then hopefully we can create some policies that can remedy some of the very negative consequences for some people. So, but I do not think necessarily that the effects that we observe, aside from the fact that it's happened very fast, doesn't give the chance for workers to catch up, for companies to potentially catch up and respond in a meaningful way very quickly. Aside from the speed, the scale and scope, probably more technologies are comparable across the history. Yeah, that's what I think, but thank you.
All right, wonderful. We have a question from Avery.
Hi, Pinar. Thank you so much for this talk. So I have a question going back to Jillian's question about generative AI. I have a question about that as well, and the kind of difference that we see in conversations about labor and the replacement of certain workers with robots or automated agents with respect to generative AI. And one thing that gets said a lot is that generative AI will kind of supplement workers' productivity possibilities so that each worker can be more productive. And what I feel after hearing your talk and sort of thinking about how that will map onto sort of skilled intellectual worker productivity is that those workers will be more productive but paid less. I don't know if you would agree with that. I don't know if I've interpreted the trends correctly from your talk, but could you talk about that? Maybe just the rhetoric around it will make you more productive, but what does that mean?
So the way that I would think about that, I guess, is like, first, as a worker now with the AI, new AI technologies, are you overall more productive than what you were doing before? Or are you just generating the same output that you did before, but perhaps at a lower cost of effort? So I think the first question we should ask is, are people more productive now with the help of these technologies? And of course, some people might be more productive, others might be equally productive, and others might be, those without the access, they might be faring behind. So that would be the first thing that I would ask. And then the second thing I would think is the distribution of these additional productivity outcomes within a firm and across the firms. If firms have now a few agents that are potentially more productive and they can only retain those agents and reduce the number of employees they have, we are going to perhaps have these individuals as winners. They might be increasing their earning potential, but there will be others who may not get the opportunity to get into these firms, work at the same jobs. So I think the overall general equilibrium effects of the generative AI, again, is as complicated as thinking about it from an automation perspective. And it's hard to make a prediction. Somehow, if these effects are concentrated at the very top, and again, is not equitably distributed across the long tail of workers, then just like what we observe, we might observe some average negative effect. Of course, there's going to be heterogeneity, but I am, again, just looking at some of the research, I think there will be some winners of AI for sure as firms and workers. And based on what we have seen, the firms that are not able to adopt AI, they are falling behind, and the workers in those firms might also be potentially falling behind in terms of what they can create and how much they can be paid. So I wouldn't necessarily say that there's going to be one single prediction, but I think it's going to be very heterogeneous, and the average effects might be, depending on the distribution, potentially negative. We should see, we will hopefully see this research, another research study explaining all these effects to us. And I'm also equally curious to see in which direction it's going to go.
Wonderful. I have a question, and I had been meaning to ask, but I wanted to give the audience the first shot, and we have a few minutes. So,
Sure.
So you talked about this negative impact on the existing jobs, and I was wondering what happens to the completely new types of jobs that might be created through the additional automation. Of course, if these are already reported in the data, they would still be categorized into one of the sectors and then would already be accounted for. But I was wondering if there is any possibility that some of the new types of jobs might systematically be not reported in the data yet. So for example, a prompt engineer may not have uploaded their CV to the database yet, and then so the database may not be aware of this new type of job and the additional kind of market career value that it brings.
Yes. So one of the challenges that we have here is trying to categorize, of course, the occupations into some standard classification. Luckily for us, the data that we inherited, I mean, we got this resume data already had classified different job titles under these standard occupational classifications. But the standard occupational classifications may also be not necessarily updated or changed frequently enough to capture some of these differences. So in some sense, those classifications that we work with, they are broad enough to say differentiate a management occupation from perhaps an engineering occupation. And if there are new engineering the definitions, new titles that are generated, that might be under that broad umbrella. So to the extent that people are moving from a sort of an old engineering definition to a new engineering definition, we are unable to capture that, unfortunately. But that's something that we thought about, whether we could observe potentially changes in the standard occupational classification definitions at a high level. I don't think that we observe such a big definition change, but again, this might be in the confounds and some of the constraints of how frequently organizations are able to, like Bureau of Labor Statistics type organizations, are able to update these definitions, and how easy it is to classify these new jobs into some of the existing classifications. So it's something that we have thought about. It's definitely something that we have thought about, and it's definitely something that I think more researchers should think about. How do we think about new jobs? Are they simply, like, are we hiring against software engineers that look not like a software engineer of 5 years ago, but maybe the titles are remaining the same, but the descriptions and the task definitions and delegation of responsibilities look very different? I think it's a very important question to think about these. At the same time, maybe we are creating new titles. New titles are definitely created. If you look at just the overall job postings data, for example, I mean, you can see the same trends as social media started growing. You started seeing a lot more social media managers as we maybe had more of search engine optimization, search engine marketing. We started seeing more jobs created with those titles. Whether these are completely new tasks or whether the titles are changing. That's an exercise that we haven't done, and I think that definitely deserves a lot more examination.
Thank you.
Yeah.
And finally, maybe we can take one final quick question. So Jack has a question on chat. Unfortunately, Jack is unable to unmute and ask the question themselves, so has asked me to read it out. Jack says, I'm wondering how much of a correlation could be applied to increased reliance on China for the supply chain and how this might have affected his jobs versus the automation. And he's kind of wondering because especially you touched on the change in political preference towards Trump in 2016 election, and Trump definitely touched on this as well in his speeches. So
yeah, absolutely. So I mean, there are a number of things that we are potentially we had on our minds when we were carrying out these exercises. Of course, this is such a difficult empirical exercise to really make a conclusive claim, and we are very careful about that. But there could be additional things going on. One of them might be the, what other researchers have documented as the China shocks, the China, it's basically the China effects, the export-import effects, and the laws that are changing, regulations that are changing around those trade effects. Trump is coming fairly late in our automation period, so I think we don't necessarily think Trump might have dramatically changed the automation exposure that we observe, but we were concerned about potentially the China shocks, the fact that there might have been a lot more, there might have been a significant change in the exports and imports with China and some of the other countries. So we do actually control for the China shocks, again using the David Dorn paper and their measures. So we try to control for that, but it's something that we think about. And in order for the export measures to somehow become a threat to our conclusions, it would have to correlate very well with the automation patterns, the robotization patterns. So and it would have to somehow also relate to the automation robotization patterns after instrumenting by the robotization patterns of other countries. So because we are instrumenting, again, the automation exposure in the United States using the automation numbers from other countries, I think we are reducing the concerns, again, of the sort of correlated export-import measures at a local market with the correlated robotic measures. I think we are trying to reduce that, mitigate that with the instrumentation. But it's definitely something that we have thought a lot about. And we, again, will continue to probably find other ways to try to see if this could be a similar explanation. We did not run the regressions for the China shocks on Trump and some of the political outcomes, but that was already done by other researchers. So we didn't feel the need to sort of replicate that.
Makes sense. Well, with that, let me thank you once again very much, Pinar, for your wonderful presentation. And to those in the audience, thank you once again for joining us for our very first seminar event of this semester. And I encourage you to please join us next week as well, Wednesday, January the 17th, as we welcome Elizabeth Joe, the Martin Luther King Jr. Professor of Law at UC Davis School of Law, for a talk on computational research for equity in the legal system training program. We look forward to seeing you all then.
Thank you so much. This was a great audience. Thank you.